All right, I think we can handle an extra transformation here. What do you think? We're going to go with a vertical stretch in this one here and some left, right, up, and down action. Let's go for it. Let's get rolling here. First thing I like to do, I want to write down my parent function. So I'm going to have y equals log base 3 of x for this one, all right? Log base 3 this time. Now, I'm going to go ahead and write the exponential form of that, which is going to help me evaluate with my backwards looking t-chart, right? Well, it still looks the same. I just pick my y values first. So I got x, I got y. Now, it's easy to raise it to the 0, to the first, and to the second power. So let's do that. 0 would give me 1, to the first power would give me 3, and to the second power would give me 9. I got my parent function ready to rock and roll. I'm not even going to plot it on this one. I'm just going to roll with my actual one that asks for in this case. So now let's go ahead and write up our next t-chart. We've got x, we got y. Now, what are my transformations doing here? We've got a vertical stretch by 2. We're going to the right 1 for this one, and I'm going up 3. So what is that going to look like on our t-chart? Well, when I'm working with my x values here, those are my left and right movements, right? And I only have one of those. I'm going to the right 1. So when I do that, I'm going to add 1. So to the right 1 would be then 2, and then 4, and 10. Those are my x values. So I'm done with my x values. It's time to get my y's. So for my y values, I'm going to have a vertical stretch by 2, and I'm going to go up 3. That does matter what order you do it in. You got to do the vertical stretch first. Think about your order of operations. It's 2 multiplied by the log base 3, and the other one's addition. Multiplication comes before addition in PEMDAS in our order of operations. Same with this. All right. So 0 times 2 is 0, plus 3 is 3. Then we have 1 times 2. That's going to be 2, plus 3 is 5, and then 2 times 2 is 4. 4 plus 3 is 7. All right. All right, so we got all of our ordered pairs here. Let's go ahead and plot them, and then we'll also get our asymptote on there as well. So here's my 3 points. Where's my asymptote going to be for this one? The graph is moving to the right 1, and since it's a vertical asymptote, when you move left and right, it makes a difference. If you're moving up and down, a vertical asymptote does not change position, right? So we're only looking at that horizontal transformation to affect a vertical asymptote. All right, so that's going to be at x equals 1. There we go. And now when I graph this, I just make sure I get nice and close to that without ever touching or crossing it. And we got it, right? And it does have an arrow right there. It was a little hard to see on the black surface there. There we go. Awesome. That was great. You guys crushed it there. Hold up. Domain and range. Let's do some domain and range. I thought I heard someone ask that. I thought I heard you. All right, domain. So domain's my x values. Does it ever stop getting negative? Yes, right? Positive 1. It does not go to it or past it. So x is greater than positive 1, or we can go from 1 to infinity, both with parentheses on that, right? My range, well, my range here never stops going down, never stops going up, right? So it's going to be y is equal to all real numbers, or you could say from negative infinity to infinity. Bingo, bango. We are done. I hope you guys loved it. I loved it. It was fantastic. All right, see ya.